Suppose you have €1, okay, and you're going to invest it. You're going to invest it in a bank and you got a very good interest rate. You're going to get 100% interest rate for 1 year, okay? So 100%, basically you're doubling your money. So you take the euro and you add it to itself and you'll end up with €2 at the end of the year. Okay, that's the first bank you go into. Now, the second bank, it's also going to give you 100%. There's a slight difference though. They're going to give you 50% of the interest, I'll just call it a half to make things easy, in the first 6 months, and then another 50% in the second 6 months. Are you going to be better off in this bank? Well, let's work it out. 50% added on is going to be €1.50 after 6 months. Then let's see, a half of €1.50 is 75 cents. Add that on, you'll get €2.25. So a little better than the previous. Now, let's just have a look. What happens if we have a euro? You might guess what I'm going to do here. And let's say that we split it into 3 sections. This is the other bank, the third bank on that same street. Doesn't give you 100% upfront. It gives you 100% cut into 3 sections. So it gives you a third of the interest in the first 4 months, a third of the interest in the second 4 months, and then again another third. So after the first 3 months, well, you'll just be left with €1.33. Now, I've worked these out actually. So we can stick this one here. So we might just keep these here. After 3 months, after 4 months you have that, after 8 months, 2/3 of the way through the year, you're going to have €1.78. Okay, so if you multiply this by 1.33, multiply that by 1.33, then multiply that by 1.33 because you're just adding on 33%, and you'll be left with €2.37. Okay, so I've done a little homework here. Now, we'll do one more. While we're at it, we'll just do one more. Okay, you have a euro and you go into the fourth bank on the street. This bank also giving you 100% but cut up over 4 intervals. 2, 3, and 4. There's your 4 intervals. Well, the first interval is easy enough to work out. It's going to be 25%, which is just a quarter. 25% of €1 is 25 cents. You add that on, that's fine. The second is just going to be adding on another 25% or a quarter. The third, you're going to be adding on another 25%. Okay, so you're up to 195, and the last one, you're up to €2.44. So yeah, it's looking like you're going to be getting more and more each time you cut it up. So would that mean as you go on to infinity, perhaps, that you'll get an infinite amount of money? Well, that's kind of what mathematicians think about. So a nice little thing to do to see where this pattern is going is try to generalize. So let's try and do that. If you can see here, we have €1. We add on a half. Okay, that gets you to €1.50. Then the answer to that, we do the same again. We take whatever the result is and we multiply by 1.5 or 1.5. Okay. Now, here in this section, we start with a euro again. we add on 33.3% or a third. It's basically the same. That result, whatever it is, we multiply it by 1.333, which is the same as adding a third. Now, we're reviewing fractions and decimals here, so if you're a bit rusty, you might have to go back and look at them. The last one here, I'm just going to do it a little bit under. Well, we're just doing it, adding on a quarter, adding on another quarter. How many times do we do this? Well, we do it 4 times because we split it into 4 quarters. Now, I hope you spot the pattern above in black. Okay, we can rewrite each of those as 1 plus a half to the power of 2. The next one is 1 plus a third to the power of 3. The next one is 1 plus a quarter to the power of 4. Okay, now can we generalize this? So here, you know, we're splitting it into 4 sections, here we're splitting it into 3 sections, here we're splitting it into 2 sections, here it's just the 1. So if we go down and split it into n sections, so n could be any number, you could split it into 12 months, you could split it into 365 days, you could split it into whatever you want, to billions, millions. What would the general formula be? Well, if you notice, it's always going to be 1 plus 1 over. Now, 4 sections, it's to the power of 4, and there's 4 in the bottom here. So it would be n on the bottom. That would be the general solution here. That would be the general equation, I should say. And it's always to the power of n. So these numbers are always the same. These numbers are always the same. The 2 and the 2 is always the same. What happens when this number gets really big? So when n gets really big, when you cut it into loads and loads and loads of sections. Okay, so you could do, you know, you could cut it into n is a million. You could cut it into 1,000,000 intervals. What's going to happen then? Well, obviously we could work them all out, and I have done, but and this might help us. But an interesting thing actually starts to happen. Now, there is a nice mathematical phrase for saying this. We say the limit of n as it goes to infinity. Okay, so as this number gets really, really big and this number gets really, really big, what happens to this? Well, I've done a little bit of work. I've got this formula, I've stuck it into Excel. Is this just going to balloon and get really, really big, you know? It's 2.4, 2.5, 2.8, and then it'll go to, you know, well, let's have a look. So some of these you'll be familiar with. That's after 2, in cutting the year into 2 sections. That's cutting it into 3 sections, cutting it into 4 sections, 2.44. Okay, so here, if we just give every month, you're given 1/12 of 100%. So you'd have 100% divided into 12 sections. Well, that there is how much you're going to get, €2.60. So it is definitely more than €2.60. Okay, 60 cents more. And obviously, if you had, you know, 1,000 here, you'd have 2,000 here. So yeah, there's be a big difference between 2,600 and 2,000. Then as we go on, now for fun, yeah, I went into Excel and I got some really big numbers here. If you cut the year into 1,048,563 sections, and you were compounded interest like we did before, using that formula that we had in the last page, that's how much money you'll get. €2.71.8 cents. So we could call it €2.72. I know I'm pointing down here, but if you notice, it hasn't really changed that much. Okay, so €2.72. And if you look back up here, it really hasn't changed that much from that. Okay, it has 10 cents, it has changed, but yeah. Now, let's go really big. Sure, why not? We have the works done out here. If you go up to 1, that's going to be million, billion, trillion. So if you cut the year into 1 trillion slices, and you give interest at every trillionth, this is how much money you'll get. 2.7, well, the 1/8 is the same, so that rounds up to €2.72. So it's the same as that. Now, obviously, this number is not exactly the same as that number. There it is to 130 decimal places. But what is the same, well, is just starting a bit here. This number here, now I mentioned this number, is getting close to E. What's E? That's pretty close. This is what E is. E is the number that you get when n goes to infinity, when n gets really big. Okay? And the strange thing that happens in this case, and this is why you'll see E in lots of compound interest questions, the strange thing is that this amount does not go to infinity as n goes to infinity. It steadies out at a very nice little number that we call E, which is approximately 2.71828 ... Is there a pattern here? No pattern. This is an irrational number, hence my heading. It's the irrational Mr. E. Okay, so there is no pattern. It's a cousin or a friend of pi, you might call it. So like pi, it's irrational, and it comes up in this funny little question. So the pi is born out of a circle, you might say. And you could say that E, well, one way to look at E is born out of a compound interest question. Yeah. So that's E, that's where it comes from. You see it all around in physics, and you see it in lots of different equations, but especially anything to do with exponential growth or exponential decay, or any type of growth, really. Yeah, there we are. Hope you enjoyed that. I'll leave you now.